Welcome to Chemistry CH110 Lesson 1. So in this lesson, since it's our first lesson, I'll first define what chemistry is, then move on to the scientific method as well as the classifications of matter. Okay, so without further ado, let's get started. So the first question which we should ask ourselves, what is chemistry? Okay, so by definition, chemistry is simply a science that deals with the composition, structure, and properties of matter and with its transformations. So in chemistry, we can actually say we'll be talking about matter, of course, considering its composition, structure, and properties, as well as the transformations or changes that matter undergoes. So from that, we can move on to what we are calling the scientific method. So the scientific method. The scientific method. Okay, so what is this scientific method? This is simply a systematic approach to research. It's a systematic approach to research. So you're saying systematic approach to research. That's a scientific method, and this scientific method actually involves 5 steps. So there are 5 steps to the scientific method, and the first one is actually observation. So under observation, when there is a natural phenomena or simply an occurrence that is taking place, scientists who observe that natural phenomena or an occurrence, so they observe that natural phenomena or an occurrence that is taking place. So when they make observation, they will try to come up with explanations based on what they have observed. So that explanation, we are calling it a hypothesis. So that's the second step. Hypothesis is simply a thorough or a tentative explanation based on a set of observations. So you observe something. When you observe, you come up with a hypothesis, which is an explanation based on a set of observations. After that, in order to test the validity of your hypothesis, you conduct experiments. So you have to conduct an experiment. So under experiments, we are simply saying, in order to learn more or to test the validity of the hypothesis, scientists carry out experiments. Then at the end of experiments, of course, you expect to have some data. Then that data that is obtained can contain numbers, or it can only contain words without any numbers, just the general information about the system. So after experiments, what do we expect? We expect to have results which will be analyzed. So let's say results and data analysis. So those results which you obtain should be analyzed. So under results and data analysis, we are saying the data obtained can be qualitative or quantitative. So the data that is obtained can be what? Qualitative or quantitative. So the data that is obtained can be qualitative or quantitative. By qualitative, we simply mean that it only consists of general observation about what? The system. So just general information about the system without any digits, without any numbers. Then for quantitative, simply means comprises numbers obtained by various measurements of the system. So by carrying out various measurements of the system, you will be able to record some numbers, and we call that type of data quantitative. Okay, so actually when the hypothesis meets the required test, so when your hypothesis meets the required test, or it comes out to be true, it has to be elevated to what we are calling a theory. So when there is some truth in what you said, there's some truth in your hypothesis, the explanation you made based on what you observed, you elevate it to what we are calling a theory, of course after carrying out certain experiments. So that experiment is the one which will prove either what you observed was what correct. So I'll come up with what we call a theory. So a theory is simply a unifying principle that explains a body of what? Facts. So it's simply a principle that explains a body of facts. Then what we must know is that a theory can't be proven. For example, if we talk about the Big Bang theory, simply talks about the evolution of life, but it can't be necessarily proven. So that's what happens. Then from there, we have to move on to what we are calling conclusion. So you have to conclude. So after analysis of data, a hypothesis can be true or false. So after data has been analyzed, it's possible that a hypothesis can be true or false. So if a hypothesis is true, of course you can do more and more experiments in order to test its validity. After that, you can come up with what we are calling a law. So that hypothesis has to be summarized into what we are calling a law. So it's called a scientific law. So this scientific law is simply a concise verbal or mathematical statement of a relationship between phenomena that is always the same under the same conditions. So we are saying that this scientific law is simply a concise verbal or mathematical statement of a relationship between phenomena that is always the same under the same conditions. For example, if you talk about Newton's second law of motion, force is equals to what? Mass times acceleration. Making acceleration subject to the formula, say acceleration is equals to what? Force over mass. What does this mean? Simply means that acceleration, of course, linear acceleration, direct proportion to force, inversely proportion to what? To mass. So this remains what? The same. This law remains the same as long as the conditions are not changed. So the definition of a scientific law, we are saying it's a concise verbal or mathematical statement of a relationship between phenomena that is always the same under the same conditions. Okay, so these are the 5 steps of a scientific method. Then let me give you just a short practical example of this scientific method. Okay, so to give you an example, I'll simply talk about something that each and every one of you can relate. Let's say we consider your phone charger, the charger of your phone. So under observation, number 1, you observe. So it's an example I'm giving you. Under observation, okay, the first one, under observation, we are talking about your phone charger. So you observe that the phone charger isn't working. That's the first thing. You observe that the phone charger isn't working. So after observing that the phone charger isn't working, of course you'd like to come up with a certain explanation. But why isn't this phone charger working? So that certain explanation you come up with is the one we are calling a hypothesis. the possible explanation you come up with for your charger not working is the one we are calling a hypothesis. So one possible explanation you'd come up with would be like, no, the electrical outlet has a problem. Maybe it's this electrical outlet which has a problem. So in order to test the validity of your observation, what do? You try to experiment. So you try to carry out an experiment or simply a test. So under experiment, what do? Of course, you plug the charger into a different outlet. You try to plug the charger into a different outlet. Then after that, you have some results. So results, you say results and data analysis. Okay, so after you plug your charger into what? After you plug the charger into a different outlet, you wait for the results and data analysis. So you see, as the phone now started charging, or maybe it's not charging. Actually, if the charger works, you have two options, two possible outcomes here. The charger will work, so charger will work, or it will not work. So if the charger works, you conclude that the original outlet has a problem, meaning your hypothesis was correct. So it means that your hypothesis was what? Correct. You can even go to what? Conclusion, saying that actually the hypothesis was correct. What has a problem is the original outlet. Then if it hasn't worked, even with a new plug, meaning your hypothesis was wrong, you have to come up with a new hypothesis. Of course, some possible hypotheses you can come up with. You can say maybe it's the charger which has a problem rather than the charger. Maybe it's the phone which has a problem. So in a similar way, even scientists do research using this, what we are calling the scientific method. So this is just as a practical example which I wanted to give you that you can relate. Okay, so from the scientific method, let's proceed to something else. So we are calling this classification of matter. So classification of matter. Okay, under classification of matter, of course, by definition, matter is simply anything that occupies space and has mass. Anything that occupies space and has mass, that's matter. Then it's possible to have visible and touchable matter, and also matter that is invisible. Visible matter, we are referring to things like water, the earth, trees. Then for invisible matter, we can refer to things like air. So that is invisible matter. Okay, then classifying matter, we are saying that matter actually can be classified into what we are calling mixtures and substances. Mixtures and substances. So we can classify matter into mixtures and substances. So let's start with substances. So substances, what is a substance? So by definition, a substance is a form of matter that has a definite or constant composition and distinct properties. So a substance is simply a form of matter that has a definite or constant composition and distinct properties. For example, if we talk about water, H2O, this is a substance. It has what? Constant composition, which is just hydrogen and what? Oxygen, and distinct properties in such a way that we can differentiate it from other substances. If we talk about what? Oxygen, even this one is what? A substance. We can talk about things like ammonia, even that one, the substance. Okay, so these substances actually can can be divided into what we are calling what? Compounds and elements. So compounds and elements, these are substances. Okay, then what is a compound? Or before we define a compound, let's concentrate on elements first. We'll get back to compounds. So under elements, we can define an element as a pure substance which can't be split into two or more substances by chemical means. So an element is simply a pure substance which cannot be split into two or more substances by chemical means. For example, when we talk about elements such as sodium, magnesium, chlorine, those elements on the periodic table. Okay, so for elements, we can say that these elements actually, when we get, let's say, sodium, the elements have what we are calling atoms. So elements have atoms. Then these atoms, when we consider the atomic structure, you find that inside atoms we have what we are calling protons, electrons, and what? Neutrons. When we consider an atom, so the electrons, of course, found in the shells. Then we talk about protons and neutrons. These are found in the nucleus. So the protons and the neutrons, we call these the what? The nucleon. Since they are found in the what? The nucleus, they make up the nucleus. So the protons and the neutrons, when you if you were to add the number of protons plus neutrons, it is called nucleon number. Then these same protons and neutrons actually consist of very small elementary particles which we are calling the quarks. So these quarks are simply the small elementary particles of what? Protons and neutrons. So the quarks make up of protons and neutrons, which end up making up the nucleus. Then moving on to a compound. So a compound simply is a substance which consists of two or more elements that are chemically combined. So a compound consists of what? Two or more elements that are chemically combined to their fixed ratio. For example, if we talk about what? Sodium is an element plus what? Chlorine is an element. If we add these, we form sodium chloride. So sodium chloride is simply a compound. So I repeat, a compound consists of two or more elements that are chemically combined to their fixed ratios. Okay. Then from there, so I've talked about substances. Let's move on to mixtures. What are these mixtures? Okay, so by definition, a mixture is simply a combination of two or more substances in which substances retain their distinct identities. So we are saying that for mixtures, substances are simply physically combined. They are not chemically combined under mixtures. No wonder we are saying that it is a combination of two or more substances in which substances retain their distinct properties or identities. For example, if we talk about things like what? Air, that's a mixture. Air is a mixture. Things like if you get what? Sand and the ion filings, you combine them, these are mixtures. Sand particles and ion filings, they will still retain their identities. So such are called mixtures. Okay. Then these mixtures have what? Types. So we have types of mixtures. And for the types of mixtures, we have homogeneous and heterogeneous mixture. So we have homogeneous mixture. So what is this homogeneous mixture? So In homogeneous mixture, we can say composition is the same throughout. So composition of substances is uniform. So the composition of substances in homogeneous mixture is uniform. For example, if you get sugar and water, you dissolve sugar in water, you see that sugar will completely dissolve in water. You won't be able to see that, no, here we have sugar, there is water. No. So such a mixture is called a homogeneous mixture. So sugar and water, this is forming what we are calling a sugar solution. So to form sugar solution, so that is a mixture. So a homogeneous mixture is actually a solution. We can call a homogeneous mixture as a solution. Then the second type of mixture is what? Heterogeneous. Okay, since for homogeneous mixture the substances are uniform or are the same throughout, under heterogeneous mixture we can say the composition is not uniform. So the composition of substances under heterogeneous mixtures is not uniform. For example, if we have sand mixed with what? Mixed with iron filings. Sand mixed with iron filings. So you'll be able to see that, no, this is sand, this we have iron filings there. So that's that type of a mixture is called heterogeneous mixture. So we can think of more and more examples. Okay, then we should know that these mixtures are separated by physical means. The mixtures are separated by physical means. For example, if we talk about what? Sand and iron filings, what can we use? We can use magnetization. So we can use a magnet such a way that iron filings will be attracted to a magnet, then will remain with sand. So that is a physical mean, and many more means we can use to separate different examples of mixtures. Okay, so these are the types of mixtures. Hope you have understood. Okay, then we have what we call physical and chemical properties of matter. Physical and chemical properties of matter. So let's move on to that. So physical and chemical properties of matter. And chemical properties of matter. Physical and chemical properties of matter. Okay, so under the physical and chemical properties of matter, we should know the definition of what? A physical property and a chemical property. So what is a physical property of matter and a chemical property of matter? Physical property, first one. The second one, chemical property. Okay, so a physical property of matter is one that is being measured and observed without changing the composition of a substance. So a physical property of matter is one that is being measured and observed without changing the composition of a substance. For example, if we talk about what? Boiling of water, melting, boiling, melting. Yeah, so we know that water can change its states: solid, liquid, and in gaseous form. So we can have water existing as what? Ice. We can have, so this is in solid state. We can also have water existing in what? Liquid form. We can also have water existing what? In gaseous, as what? Water vapor. So when these changes take place, these are examples of what? Physical changes. So we do not change the composition of a substance. The composition of a substance, water, which is H2O, either at ice stage to remain that, at liquid stage to be to H2O, even at gaseous stage it is H2O. What is changing is simply the what? What is changing is simply the state of matter. So the states of matter are the ones which are changing, but it's still a physical property. Then what about a chemical property? What is a chemical property of matter? So a chemical property of matter is one which is observed if there is a chemical change. So a chemical property of matter is one which is observed if there is a chemical change. For example, if you have what? Hydrogen. Let's say you react hydrogen with what? You burn hydrogen in oxygen. You find that you have H2O. Initially you had hydrogen and oxygen separately. Then you burn hydrogen in oxygen. You find that you end up having H2O. So here a chemical reaction has taken place. So a chemical property is one that is being observed if there is a chemical change or a chemical reaction that is taking place. So hope you have understood the differences between a physical and a chemical property. So from there, let's talk about the last thing for this video. Categories used to measure properties of matter. So we have the categories used to measure properties of matter. Used to measure properties of matter. Properties of matter. Okay, so we have two categories that are used to measure two categories to measure properties of matter. So what are these? The first one, we have what we call an extensive property. So the first one is an extensive property. Okay, so what is this extensive property? So what is an extensive property? So an extensive property actually depends on the amount of matter present. So this is simply a property which depends on the amount of what? Matter present. So it depends on amount of matter present. Okay, so this one depends on the amount of matter present. What does this mean? This simply means that the more matter we have, the more mass. So the more matter, the more mass. Then examples of extensive properties of matter, we have mass, volume, and energy. These are simply some of what? The examples: mass, volume, and energy. Then what we should know is that these extensive properties of matter are additive. They can be added. The extensive properties of matter are additive. They can be added together. For example, let's say you have a mass of 10 kilograms, another mass of 2 kilograms, then another mass of 1 kilogram. So if you put together these 10, 2, and 1, you find that you have a total of 13 kilograms. That is what we mean by extensive properties are additive or can be added. Same as volume. You have a 20 liter volume of water, another 20 liter. You can add them together to find the total. Same as energy. You have 10 kilojoules plus another 4 kilojoules. So you can add them to find the total. So let's talk about the other properties so that we can differentiate them well. So the other property is called an intensive property of matter. Intensive property. So we say that under extensive property, so extensive properties simply depend on the amount of matter present or amount of matter being considered. Then that is not the case for intensive properties. Actually, intensive properties of matter does not depend on the amount of matter being considered. So for these ones, do not depend. So they do not depend on the amount of matter being considered. Do not depend on the amount of matter being considered. Or the amount of what? Matter present. Okay, do not depend on the what? Amount of matter being considered. Then that is an intensive property. Then let's give examples so that we can differentiate extensive and intensive properties. So I'll give two examples: density and temperature. So density and temperature are some examples of intensive properties. So these are not additive. Okay, so these are not additive. Let's look at what we mean by this. So let's start with density itself. I'll give an example of the density of water. So the density of water is about what? The density of water is about 1 gram per cubic centimeters. 1 gram per cubic centimeters. This is the density of water. Okay, let's say we have water in two different vessels. We have water in two different vessels or two different beakers. In this beaker there is water. In this beaker there is water. And in another beaker, okay, let's use three different vessels. In another beaker there is water. So in this, since it's water, it's all water. In this vessel, you say the density of water is what? 1 gram per cubic centimeters, 1 gram per cubic centimeters, 1 gram per cubic centimeters. Then if you combine water from this vessel, that vessel and another vessel, and try to use a larger vessel. Let's say we try to use a larger vessel. We pour water from vessel 1, vessel 2, and vessel 3. We pour water from these vessels into this larger vessel. Can we say that the density of water should be added as well, 1 plus 1 plus 1, in order to have 3 grams per cubic centimeters? No, of course. It shouldn't be like that. Since it's water, its density will remain the same, 1 gram per cubic centimeters. That's what we mean by saying this. The intensive properties are those which are not additive. Then let's consider temperature. Let's say we have under temperature, let's say we have two different liquids. One liquid as water, let's say, which at 30 degrees Celsius. Then the other liquid as water, which is, let's say, at 10 degrees Celsius. We have two different liquids. One with water temperature 30 degrees Celsius, the other temperature 10 degrees Celsius. Then let's say we put those two liquids in one vessel. We put those two liquids in one vessel. So can we say to find the total temperature of the combination of two liquids will be 30 plus 10, which gives us 40. Can we say that? No, of course, we can't do that. So these are simply examples of intensive properties. So take note that intensive properties are those that are not additive. So you can't just add them like that. But for extensive properties, you can add them like that. It even makes sense. Okay, so that's it for this video. I hope you have understood. See you in the next lesson.